Okay, hi and welcome to the first video where we're going to learn a little bit about our laws of indices. Now if you remember back to your GCSE lessons last year and what you needed to know for your paper, quite a number of different laws that you need to know. So I'm just going to recap them all now very quickly. So laws of indices. And if we think about our first law, which we'll just call law 1. First couple I'm not going to go through in great detail because they are the ones that we tend to remember quite well from our GCSEs. So if we have law 1, and if I were to give you a question, something like, zoom in a touch, there we are, something like a cubed times a squared. We could think about this as being the first section, obviously, a times a times a times a times a. Effectively we're multiplying a together 5 times now, which when we look at our rules we can see that that's just going to be 3 plus 2. So the answer to this one would equal a to the 5. And in general then, for your notes, this would be a to the m times a to the n equals a to the m plus n. So when they're multiplied, what we do is we add those two index numbers together. Okay, let's go back out a touch then, and we'll start on law 2. Law 2, which we can move around, and it should come with me down here. Fantastic, perfect. Okay, law 2 then. Let's go in again and touch, and our law 2 is going to state effectively the opposite. We're playing around with these operations for our indices, and if we gave you a question like a to the 5 divided by a, oops, have I used 5 twice, to the 2, that would equal, hopefully we would remember this. What we need to do is we need to look at our, first of all obviously our base numbers are the same, that's important, but what we can do is we can just do 5, take away that 2, and that would give us a to the 3. And that's because they cancel one another, numerator and denominator of a fraction. And we'll explore this a little bit further as we go now. So, general rule then, let's go red again then. If we had a to the m divided by a to the n, that would be the same as a to the m minus n. Okay, what I want to do now is play with this a little bit. We've got this second law, and that's going to be really useful for us to find out what happens in certain situations. We're going to have a look at now what happens when we play with and we create a negative number as our index number. So what I'm going to do is I'm going to play with this across somewhere else. We're going to leave this over here. We'll come back to it and add to our laws, but for you, you can continue with your notes down and we can just start to play with something like, let's just say, consider. So we're going to consider this next scenario, which is going to be something like, let's just say, let's do a, again we'll stick with a to the 3 divided by a to the 5. Okay, what's happening here then? Well, if we were going to write this out in full, which would have been our way of deriving that second law, what we would have, we could say that this is equal to the top bit, which is a times a times a. I need to go slightly smaller, try and keep it neat. A times a times a, that's my a to the 3, and that's divided by, well, I'm not going to have space to do this, a times a times a, now that's divided by the a to the 5. A times a times a times a times a. What's happening then, as we kind of alluded to slightly on that law 2, is whenever there's something on the top of a fraction and the bottom that's being multiplied together, they can cancel one another out. So this a here, because the whole of the top's being multiplied, can cancel with something that's the same on the bottom, because the bottom's all being multiplied. Again, this a will cancel with this a will cancel with this a. And what we've got there then we can say that this is equal to 1 over, and what we've got at the bottom over here is an a times a, right here. We've just got these two a's left over, a times a. So that's the same as, we know, 1 over a squared. So let's just put the things that we know together to kind of get a general rule of what's happening. Our starting point was a to the 3 divided by a to the 5 equals 1 over a squared. But using our second law, what we can do is we know that we can take this number, this 3, and because it's divide, and because both of them are the same base number, this a, we can subtract this 5 from it. So if I was going to simplify this and do 3 minus 5, I could say that that's the same as a 3 minus 5 to the minus 2 is equal to, well, what have we shown it's equal to? It's equal to this over here. So it's equal to 1 over a squared. And that is what you're going to have to remember for a lot of your things that you're going to have to apply in your C1 module. So when we've got this negative indice, this negative index number, it's effectively the reciprocal of that, whatever that number is, that 2, 1 over a to the 2. So if we were going to have a general rule, if I was going to articulate myself properly, let's do this in a general rule because it'd be much easier to see then. If we have a base number to a negative number, say a p, doesn't matter what it is, in our example it was a 2, that would be equal to 1 over a to the power of that p, 1 divided by a to the p. So it's effectively a to the minus p is the reciprocal of a to the p. Okay, so let's head back and put this in with our other rules. Oops. Okay, what are we saying? Where are we? Ah, law 1, law 2. There we are. Okay, so makes sense. Let's put in law 3. Which isn't going to go there. Okay, that's fine. Law 3, which is going to be black. And that'll do us. Right, so just move down. So this is kind of our reciprocal, and we're just saying here that, and I'm going to go straight for the algebraic one, so I'll go in red like the others. What did I say? I said a to the minus p is equal to 1 over a to the p. That's one that people always forget. So make a big point of that one, highlight it, whatever you need to in your notes. A to the minus p, hopefully yours is an e to the mine looking at it, equals 1 over a to the p. Okay, yet again, what I'm going to do is I'm going to go away and I'm going to play with this law 2, this idea of setting up a division and subtracting those index numbers. And I'm going to create a situation not with a negative now, but where we have to the power of 0. So we can kind of see what happens there. Now we know that anything to the power of 1 is itself. So anything to the power of 1 was itself. Let's just have a look at what anything to the power of 0 is. Let's create this situation again by considering a real life question. So if we've got a to the 4, oops, it's rather large, divided by a to the 4. Okay, again let's write it out in full. This would equal, I'm going to go underneath in fact, and I'm going to change my colour, a times a times a times a, and that's being divided by a times a times a times a. Again, we've got this wonderful situation where we can cancel top and bottom and simplify our fraction. These two go, these two go, these two go, these two go. Everything has cancelled itself out. So effectively we're multiplying and dividing by the same thing, which will leave us with an answer of equals 1. So anything to the power of 0, that's what we're looking at, because we'll have this 4 from our original divided by a to the 4, means we subtract 4 from 4. 4 minus 4 we know is 0, so a to the 0 equals 1. And that's going to be the next thing we're going to write about. So let's go back, we should be able to find our next one, and law 4. law 4, which is going to state that anything to the 0 in fact equals 1. Anything to the power of 0. It could be 2 to the power of 0, that equals 1. It could be 563 to the power of 0, that would also equal 1. So that's just something to kind of bear in mind and just not be caught out with. Okay. Next we're going to think about, for our next law, quite a few to get down, as I said, a few to remember. Our next law is going to be about raising powers of powers. So, law 5. Okay, again what I'm going to do is I'm going to just think about this in a real life context, or a tangible context, then we'll generalise with our algebra. So, let's think about what it means to have a squared to the power of 3. A squared to the power of 3. Well, what that means is this 3 to me says that I've got to do whatever's in that bracket multiplied by itself 3 times. So what I've effectively got is a squared times a squared times a squared, which we can remember, if we recall from our first law. Let's go up and have a look at it. As soon as we're multiplying things together, looking here now, as soon as I'm multiplying anything to the m times anything to the n, we add these two index numbers together, and that's a similar situation to what we've got now here in our fifth law. We've got now this a to the 2 times a to the 2 times a to the 2, so we can just add those 2's together, and that would give us a to the 6. Now what we try and do is we try and make a link between this starting position, a to the 2 to the 3, and this a to the 6. And I'm sure you've all spotted it already. What we can do now is, to get straight from the start to the end, is we can take our 2 and our 3 and multiply them together. So what we would have as a general rule, in order to get this, we would have, let's go red for our general rule, if we had a to the m to the n, it would equal a to the m times n, which we can just write as a to the mn. Okay, our final one to consider then, the last thing I'm going to show you now. This one's going to be conceptually challenge us a touch, but if we kind of just apply the laws that we know already, we should be able to see what's happening and how it's kind of come about. So, law 6, and we're going to be exploring now the idea of fractions, fractional numbers making up those indices, and what that actually means in itself. What I'm going to do for this is I'm going to draw on our first law, which we've kind of just touched back upon. So that law 1, if we remember, when we've got things multiplied, we just add the index number. So, again, I think I'm going to work off to one side and come back, and in our nice notes, put in the general rule. So, let's just consider, again, like considering, consider this situation, and it's going to be that something to the half times something to the half. We've created now this fractional index number that we're looking for to try and understand a little bit, and so we need to, because we're multiplying them together, if we were to write this, we would say that that would equal a to the power of a half plus a half. Half plus a half, we know, is 1. And we also know, this is quite nice, we also know that a half, a to the 1, anything to the power of 1, is just that number a. Oh, that base, whatever it is, to the power of 1 is just itself. So, let's just jump ahead then. What we've got is a equals thing to the half times a to the half. Now, what we need to notice here is, yes, we've got this number But on this right hand side over here, what we've got are two identical things being multiplied together. So we've got this thing, whatever it is, a to the half, multiplied by the same thing, a to the half. And those two things combined give us the result of our original number, if you like, that base number. So, how something multiplied by itself to give the answer a, well, that must be the square root of a times the square root of a gives you a result of a. So, we can just generalise from this. If these two are the same things, we're saying that a to the half is equal, it's the same as the square root of a. And that's going to be our next kind of idea that we're going to put in. So a to the half is equal to the square root of a. And this works in much the same way for square roots, cube roots, and effectively nth roots. So our general rule will be, which we're going to put in on the other side in a second, a to the, if we've got that fraction as 1 over, it could be anything, let's just say 1 over, what have we been using, m's, m equals the mth root of that a. That's what we're going to put in as our next law. So back to our laws. And we're on number 6, are we? Superb. Okay, so what do we say? I've just said that a to the power of 1 over m is equal to the mth root of whatever our base number is, a. Okay, so let's have a little look at what we've got. We've effectively got a load of scribblings on the right, but we've got 6 laws. First, second, should have seen before. Hopefully 4 and 5 are also stuff that you can recall from your GCSE days. Third one is one to remember. That's the one that catches people out. And finally, that 6th one might be new to some of you. The idea of 1 over m being the mth root of whatever the base is. Now, the only thing you're going to be asked to do beyond that is apply these rules in context. So I'm just going to run through a typical tricky question that you might have. So, let's just say you are asked to simplify, for example, let me just move this out of the way. Let's just simplify. Doesn't matter if this is big. Oops, simplify. And it's going to be something like 1 and 9/16. Oh, a bit of practice with our fractions. And that's going to be raised to the power of 3 over 2. Okay, first thing I would do in this instance is I would convert our fraction into a top-heavy fraction. So let's just recap how I do this. We take our 1 and we multiply it by the denominator. 1 times 16 is 16. Then I add on the 9 to the value I've got. So 16 plus 9 gives me 25. Okay, so what I've got then effectively, move myself down a touch, is I've got 25 over 16, which is being raised to the power of 3 over 2. Now, you're probably looking at the 3 over 2 and thinking, oh gosh, I've only seen something with a 1 at the top here, so I only know what to do with that. But what we're going to do is we're actually going to use the idea of this law of 5 first, and we're going to manipulate it so that we've got that situation where it's 1 over something, so we can use that root. So, let's think about how I can change this 3 over 2. I want to change it to 1 over, so I'm going to have, if I write this out again, 25 over 16. Now I know what that 2 a half is, because that just means the square root of it. But I'm not finding it out to the half, I'm finding it out to the 3 over 2. So I can raise that to another power of 3. Now, if we've got a power raised to the power, remember we multiply them together. So this is just the same as to the power of 3 over 2, but I can deal with them individually. So, let's just have a go at this. Let's have a think about what, first of all, my inside bracket is. 25 over 16, all raised to the half. Well, that just means the square root of 25 over 16. So if I write this out, it's going to be the square root of 25 over 16. Now we're going to do more with our surds as the next thing we're going to do. Obviously this is all cubed. But the square root of 25 over 16 is just the square root of 25 over the square root of 16. So what I've got here is the square root of 25 over square root of 16, which again is still all being cubed. What's quite nice is I have two square numbers here which are being square rooted, so I can just complete that operation and kind of tidy things up a little bit. Square root of 25 we know is 5, and the square root of 16 obviously we know is 4. So let's go again, move down, and just simplify this a little bit. So what have we got? 5 over 4 to the power of 3. Now in order to apply that, I'm just going to have to do 5 cubed over 4 cubed. 5 cubed over 4 cubed, which should equal, let's have a little think, 5 times 5 is 25, and multiply that by 5, that's going to be 125. And that's going to be divided by 4 cubed. 4 times 4 is 16, times 4 gives you 64. And that'll be our final answer, 125 over 64. And there we have it. We have reached the end of our video. So, we're going to do a little bit more application of this, and there's a lot of time for us to practice and for me to go through this with you. But you now have the overview of the theory that we're going to be asked to use, and that's using these 6 laws of indices, which I would hope now will feature as your notes ready for the start of next lesson.